Before we start, I would like to introduce Varun. Varun is an inventor, technologist, entrepreneur, and a visionary leader in the field of 3D design and visualization automation for the last 15 years. He's a thought leader who is driven by his passion for enabling businesses around the globe in the AEC and manufacturing industry to become better, smarter, and faster by creating innovative and powerful design and visualization technologies. After working with giants like GE and 3D PLM, he started nCircle Tech in 2012 with the vision to automate the design workflows. He is an IIT Madras alumnus, a father of two adorable sons, and also an awesome badminton player. Varun, thank you for being here.
Thank you, Kushagra, and thank you all for joining. I hope this session will be worth your time.
So without further ado, let's get started. In today's live session, we will explore how technologies like artificial intelligence and machine learning can usher in Automation 2.0 and create a sustainable impact in reducing the global carbon footprint. So Varun, before we dig deeper into scan to BIM automation, what are your thoughts on the ongoing climate crisis?
Well, the climate crisis has been one of the focal point of the 21st century, both within political circles and construction industry. From Greta Thunberg calling upon to the world leaders to President of USA Joe Biden running for the office on the agenda of climate change, the call to action is just getting louder. We are all aware that about the heat waves spreading across Europe, with many countries facing record high temperatures. The scenes of firefighters tackling wildfires seem very close to the scenes from world-ending movies. Did you know that according to the World Meteorological Organization, there's a 40% chance that 1.5 degree temperature threshold will be exceeded by 2025. In year 2021, IPCC released a report that revealed the severity of inaction on climate change. COP26 and G7 summit have resulted in a firm commitment to sustainability, and many countries have taken aggressive carbon goals. We are all realizing the impact of climate change. I have two young sons, and the thought of them facing the end of the world in the near future is terrifying. Hence, the only way forward is that we become more optimized and more efficient to clear our carbon debt and build sustainable future for next generations.
Well said, Varun. I think parents like you are eventually going to save the world. I'm glad you spoke about reducing our carbon footprint. Here is this graph that will give a breakdown of the global carbon emissions. As you can see, the architecture, engineering, and construction, also known as the AEC sector, are responsible for around 39% of the global greenhouse gases. So can a more optimized and efficient workflow in AEC bring a significant contribution to curbing climate change?
Absolutely. One such key initiative is Golden Thread Initiative. Since its conception in December 2020, many organizations have joined to help pilot ways that organization can produce standardized digital golden thread for both existing buildings and new builds. In order to retrofit to reduce carbon emission, we need to quantify the energy requirements in existing state of the buildings and improvements possible. To deal with this, we need digital data. Under COP26 and Golden Thread, UK needs to retrofit 26 million homes by 2050.
Interesting. I would like to pull in our audience here and ask them about, is anyone dealing with such aggressive carbon reduction targets? How are you handling it presently? Please type in the chat box. So Varun, coming back to the number 26 million homes, that's quite a big challenge, isn't it?
Yes, let me break it down for you to truly understand the scale and enormity of this. Can you guess the total number of houses to be refurbished for energy efficiency per day? The calculation turns out to be about 2,600 houses per day. Do we have digital models for these houses? No. Hence, there is a need to innovate, and there is a need to speed up the process to achieve our goals. And we need a lot of data to estimate all of this. We need 3D models to make this happen faster.
So is that where Automation 2.0 comes in?
Simply put, automation 2.0 is increasingly optimizing every workflow. We are moving from reactive to predictive and proactive approaches. Considering the evolution of new computing technologies and artificial intelligence, automation 2.0 is not just a buzzword. Instead, we are in a phase wherein computers now can learn from experience and from the data. Computers can often do better prediction of patterns as compared to humans.
So is that where scan to BIM comes into the picture?
Scan to BIM is a term often used these days in BIM industry. Scan to BIM has emphatically influenced AEC industry by speeding up the digital modeling processes by providing as-built models for retrofit in a very cost-effective manner. However, the current typical workflow for scan to BIM involves laborious task of taking the registered point cloud data and turning them into BIM models, one entity at a time. This creates a big barrier for adoption of scan to BIM. Hence, automation 2.0. With automation 2.0, we can leverage the power of AI/ML and make scan to BIM smarter and faster.
That makes sense. So my next question to you, Varun, is how does scan to BIM help reduce the carbon footprint?
Scan to BIM helps to reduce carbon footprint in multiple ways. First is definitely speed of conversion is significantly improved. This enables us to operate with same team and do more in less time. Exponentially, the second important is exponentially higher accuracy of quantification. When we adopt traditional approaches, engineers often make certain assumptions. If total square feet area is so much, probably the heat loss would be around this much and so on. But with accurate BIM models, each of these calculations are far more accurate and BOQ calculations are like accurate to the point. Last is the digital copy that gets created as a part of this process is also useful in initiatives like Golden Thread and becomes a long-term archive of digital data.
That sounds really exciting. Can you dig deeper and explain how artificial intelligence and machine learning does this?
Yes, sure. Let me actually show you a demo of what we have accomplished in this process. I hope you can see my screen.
Absolutely, Varun.
So what we have is the point cloud data as I was showing on the screen. All we ask as an input to the user within Revit environment to provide E57 file as an input. What then happens is this point cloud is sent to the server. It processes it, analyzes the point cloud data and comes back with the JSON file, which is then used to create BIM entities within Revit. Now, the hope is to create that magic button which really converts anything and everything automatically into BIM model. But let me show you what we have accomplished. So this is the output that is generated all automatically from the point cloud data without any user input. Beyond this, user is just trying to validate and verify if everything that has been created by the automation of machine learning is accurate enough to proceed with the next stages. Let's take sections on the first floor. As you would notice, walls with different thickness, doors, windows, lot of that data is right, like accurately placed. We can check similarly on the ground floor as well. You can see a lot of model lines getting created. These are all approximations that the system creates automatically to create right accurate walls in right places. We're not only creating the walls, but we are creating doors, windows, all accurately because these are very important for the heat loss calculations. Let me show you exactly what is happening in the background of how we are turning this point cloud data into an accurate BIM model. So this is original point cloud data. This point cloud data is also cropped automatically based on the density of points available in the scan. So we zero in on the exact building that is of interest. Now here's the core magic of machine learning happens. The intelligence that it adds to the system is these group of points are wall points. Think about it, without any original point cloud just has color and XYZ values. But with machine learning, we are grouping these points together to call them that this group of points are actually wall points and these group of points are door points. Like you can see a door around here and the windows created around here. This is very powerful and helps us do a lot of things. Some more sections of the same data you can see inside furniture also classified separately to create different kinds of understand what group of points represent what kind of entity. Now, because the data is classified, we are able to extract only the wall points, which are then fed to all our statistical approaches to create accurate walls. We take these wall points, then we do all the plane fitting, create the exact, these are different planes identified, which are then combined together to represent wall. We find interior walls, exterior walls. All of this data gets transformed into a JSON file, which is readily consumed in Revit to create a final BIM model. So here's the first cut BIM model, all created automatically from the with the help of machine learning. Now, our larger goal is to speed up the entire process of scan to BIM. So we've not just stopped at automating the BIM model creation. We've also tried to speed up our process of QC checks. Before this approach, traditional approach is modelers create sections at every 1 feet and then try to look through the entire data to understand what is deviated or what is not modeled and everything, and it is so error prone. We face so many issues when that was happening. This system, this plugin creates a very good heat map of everything that has been modeled and everything that has been deviated from the given modeled entities. Let me show you this in sections. As you would notice, anything that is very close to the corresponding entity in Revit is marked in green. Then, so that is 0 to 20 millimeter deviation. Between 20 to 50, things are marked, points are marked as yellow, and 50 to 100, anything above 50 is marked as red. This helps us spot any kind of deviations and issues very, very quickly, and thus making our process of final quality of our deliverable very, very accurate as required. This just speeds up the process of QC as we go along through top to bottom. Everything, every change in the model, everything that is missed is very clearly identified. As you will notice, a lot of furniture which is not like really impacting the heat loss calculations are not modeled, but definitely speeding up the process and bringing accuracy in the model. Now, again, as I said, we've not stopped at creating BIM model, doing the accuracy check. The very important thing is how do we do heat loss calculations? So heat loss calculations require a lot of quantification output. You need to understand all the wall surface area. You need to understand what are different rooms above and below, what is my floor area and everything. So we generate tons and tons of data in single click, which is useful to understand exactly all the wall surface that can be insulated to keep the heat inside. We also find a lot of adjacencies between the rooms, so that because you may have some rooms which are heated and some rooms which may not have any kind of heating. And this also impacts a lot of heat loss calculation. So all of this plays a big role in calculating all the heat loss and thus coming up with an accurate tech survey, which then feeds into the next set of processes. Highlighting this overall, right from taking the point cloud data to creating the BIM model to accuracy check to generating all the calculation output, the entire process is speeding up every process, every step of the way to ensure that we deliver speed and convert as many BIM, point cloud data to BIM models as faster. Shagra, I think you're on mute.
Yeah, thank you so much, Varun, for popping the hood. I think the audience got really excited, and I already see some questions flowing in. So, audience, please please feel free to put these questions. We will take all these questions together after the end of this conversation. We have a Q&A plan where Varun will answer each and every question for you. So, Varun, we have already seen now how it works. So, what does it mean for the end user and turnaround time? How much optimization are we talking about?
So the UK energy company for whom we were doing this entire scan to BIM and heat loss calculation was had a turnaround time of about 8 to 10 days, like right from taking the scans to converting that into BIM model, and then eventually doing all the heat loss calculation. And not to mention, it was still somewhat error prone. With all these automation that we've implemented, using machine learning, scan to BIM, so all the accuracy checks and everything, we were able to reduce the turnaround time to 2 to 3 days. That's in itself is about like 80% saving in time.
That's the power of smart automation, isn't it? While we move on to our next question, before that, I would like to take this opportunity and again involve our dear audience. So, dear audience, how are you doing scan to BIM today? Please answer it in the chat box. So, Varun, as you were talking about retrofitting these 26 million homes in the UK, do you think that our ML powered scan to BIM technology would be a strong fit for such a use case?
Yes, absolutely. Machine learning is a very probability-based system, and more repeatable data, and even doing bulk scans of similar properties. This is an absolutely perfect use case, like application of scan to BIM technology. Imagine like really converting 2,600 houses a day. It would need astronomical amount of workforce, and this would make really such initiatives impossible. But we can let machines do a lot of that heavy lifting. With traditional approaches, humans would model this one entity at a time, and this would consume so many human hours. So to retrofit these homes and make them energy efficient, we need to adopt such innovative solutions and make use of technologies like ML powered scan to BIM and any automation possible. This is very, very critical to realize our dream of energy transformation and for the net carbon zero future.
So, Varun, while you were answering my question, the audience replied to the question that was thrown to them. So, I think till now, what I'm seeing from the responses from Harry and Andrew is they have been using the traditional scan to BIM approach, and the challenges probably they are facing the same what you were talking about. So, audience, just out of curiosity, anyone amongst you working in the field of bulk scanning or bulk digitization, type yes in the chat box. Now that we have seen how scan to BIM works, for our viewers, Varun, would you be kind enough to list down the advantages of the entire approach?
Yes, definitely. Like I have highlighted multiple times, the speed of scan to BIM is everything. With the speed, I mean, I have realized in my experience, more than the cost, people are very happy with the speed and the turnaround time, because things move just faster with scan to BIM process. Second biggest advantage is it really avoids this entire approach that we've created, actually going and scanning the entire house and then capturing all that data. It may sometimes seem an overkill for a very simple application, but the beauty is this avoids multiple visits. Owners really don't like when you have one visit for wall insulation, then someone else visiting for air source heat pump, then someone else is visiting for solar panels. You can't get so many appointments from the owner for all such upgrades. But with scan to BIM, because you are scanning the data, you can use it in multiple ways and it avoids all these kind of multiple visits. Because we have scanned the data, it also is like a digital reference. You can always cross verify the data, any BIM model, anything that you've created out of it. It is easy to cross check and cross verify, making it a very robust system. The output generated as a BIM model is compatible with many different downstream applications. But the most important thing that I want to highlight is this approach really created, and we ourselves were surprised by this fact, that this approach created so much of a premium experience for the end users, I mean homeowners. They really like the fact that team of people with this advanced scanners on the shoulder, drones flying around, capturing all your house digital data. For that, although this happens, entire house gets scanned within 20-30 minutes, but in that 20-30 minutes, it is a very premium experience for the homeowners. It almost seems like right from the Star Wars, those stormtroopers are getting into your house, doing all their fancy stuff, and they are out with all the information within like 20-30 minutes. This just gets more and more participation by the spread of word that, oh wow, I think I paid for a premium experience and I'm liking it.
Varun, now you mention it, and then looking at the Star Wars troopers, stormtrooping in my house as a house owner, I think I'm really excited to actually give these guys a call and tell them, can you come over and actually make my house energy efficient, just for the experience sake, just to experience how drones work, how the whole digitization of my house design will be done. So Varun, we have spoken about scan to BIM, how machine learning is changing the game. What do you believe is the future of scan to BIM technology?
Well, let's take a look at the history, Kushagar. Long time back, when I was a kid, there were many, and this must be very funny for a lot of the audience as well. There were many data entry companies in India. Literally, they used to have hundreds and hundreds of people sitting on the old style computer. They used to get a photograph of a hand-filled form, and someone is reading that hand-filled form and typing in whatever digitizing those handwritten forms. Such companies have vanished now. Why? Because of the advancement of OCR. Then let's look at what happened with photos. Earlier, photos were dumb photos. Then soon, these, with the help of whatever technologies Facebook, Google, and others have developed, these photos were started getting tagged automatically. This is a photo of Varun, this is a photo of Kushagra, and so on. To an extent, Google can now even describe the photograph. If you present a photo, it will say this is a photo of a boy playing with a ball or something. I think something similar is required in the 3D point cloud data. Number of photos over the internet increased exponentially when the cameras were added to the mobile phones. Everyone was capturing photos. Now we see LiDAR scanners getting added to iPhones and iPads. How long is it when even the point cloud data scans are going to really explode? We are going to have so much of point cloud data on the internet. There has to be someone making sense out of this data. That's where machine learning powered scan to BIM comes in. It can extract so much useful information from the point cloud data automatically, thus enabling really innovative workflows for the future.
That makes sense, Varun. And in fact, how artificial intelligence and machine learning can really make these design workflows easier, faster for all of us, that comes out very nicely here. But as a human, and then seeing all those sci-fi movies while I was growing up, especially Terminator, the Judgment Day, there is a small part of me that is always fearful of these technologies. And I'm sure there might be the same kind of trepidations in our audience members as well. A slight maybe that when it comes to artificial intelligence and machine learning, they might replace us as humans. And especially in AEC sector, this fear is quite spread across. So people fear that such technologies will come in and take their jobs away, whether it's in project delivery or whether it's on-site. So do you think these fears have some kind of a base, some kind of a rationale?
I don't think so, Kushagra. I mean, people thought about something similar when computers were like becoming a very household thing. Everyone thought with the advancement of computers, there will be less requirement of human workforce. I think that has never happened. Technology has just never replaced human. It has always assisted humans to do more. And even if there is some replacement happening, we have so much of carbon debt to clear. There are so many houses to refurbish. The energy consumption that we are doing right now is astronomically high. We need power of every automation possible to ensure that we have a better future. I have no doubt that this technology or any advancement similarly has any negative impact on the humankind. If anything, it has only to make future better for all of us and all humankind.
Varun, that was very nicely put, and I think it really put fire to the put water to the fear that was somewhere inside me, and I'm sure the audience feels the same. So, my dear audience, the discussion we had today, it was a very specific use case and a workflow on how our AI ML powered scan to BIM technology can make the design workflow smarter, faster by solving larger than life matters. However, I'm sure each one of you has specific processes at your end that you follow. Varun will be more than happy to spend a few minutes on a one-on-one call with you to actually look at your specific process and advise those technical modifications and automations that could help you reduce the turnaround time of all your workflows. I'm putting the link to Varun's calendar in the chat box here. You can pick and choose a slot in case you want to consult with Varun. Thank you so much, Varun. Last but not the least, before I let you go, how can we access this wonderful technology for our audience who has been listening to this discussion so curiously?
Thank you for bringing that up, Kushagra. I think same is the question from Scott from the audience as well. So Scott and everyone else who have this question, many people are behind us to release this technology, and my team is working around the clock to make this happen. We're planning to release this technology by end of this year. But in the meanwhile, we are helping our clients through a managed service who would and where my team is able to work with any inefficiencies currently that we have of the machine learning output, but deliver quality BIM models, which is a value add to the end user. If you are very keen interest in the technology itself, I'm happy to jump on a call and explore possibilities of providing early access to this technology or exploring how we can synergize together. We also have a try now page, trynow.scantobim.ai. You can upload point cloud files on this platform. It will return back with a corresponding Revit model within matter of hour or two. For smaller models, maybe within few minutes. You're happy to give it a try. It is specialized for houses kind of model. So those are the best to process. And I think for anything else, we are happy to talk further and see how we can align end objectives better. With that, I think that's all from my side. Thank you, everyone, and thank you for your time today. I hope you enjoyed the session.
So thank you, Varun, for this awesome fireside conversation. Guys, as you will see, we have already put the link in the chat box for the try now of our scan to BIM technology. And I can already see audience are interested in a lot of questions coming in. So Varun, I'm absolutely sure that this technology would do wonders for any company looking to automate their scan to BIM workflows to save their time and eliminate rework. I have already bombarded you with a lot of questions. It's time I open the floor to our amazing audience. So my dear audience, I'll be taking the questions that are already there. In the meantime, please feel free to put on more questions and we'll take them one by one. So Varun, one of the first questions I'll be going in first come, first in, last out. So Noman is asking, is this technology supports MEP modeling?
MEP, unfortunately, is a far more complicated beast to handle. We are not supporting MEP yet, focusing on architectural element. I have few questions from audience as well. So from Jim, can this technology cater to small scale and large scale project with attention to detail? Yes, Jim, we can support a lot of large scale projects, high rise buildings and such. But focusing on mostly architectural elements at this point. Really working with all different kinds of data, processing it. I mean, machine learning has been trained on different kinds of data to process even large scale projects. Obviously, we chop it internally before we process, but it's able to handle large scale projects as well.
Hello.
Yeah, I think I'm just taking the question directly. I think I have one question from Dave. Can it return IFC models? Dave, currently it is returning a JSON file which can be used to create entities based on the JSON file. For a lot of integrations that we are exploring currently, I think JSON file makes a better choice because you have all the information defined very clearly from the JSON. But we can enhance this to create IFC files as well. We have worked, Scott, on CAD and PDF to BIM solutions as well. Maybe that calls for a larger discussion, but I have some demonstration that I can share with you on the PDF to BIM or even CAD to BIM, both use cases. Repeatable data makes it easier to make that workflow more and more accurate. What is question from Noman? What will be the biggest effect of AI-powered scan to BIM on reducing carbon, and what will be the contribution of it towards net zero? I think I can't say what has the biggest contribution, but definitely starting point for achieving carbon zero is knowing what and how it exists as it is. So this is, I believe, is step one in the many steps forward. It will accelerate the carbon zero, net zero initiatives. Without this, it is very difficult for me to imagine how we are going to meet such aggressive goals.
There is one more question, Varun, by Bharti, who is asking accuracy level of the wall detection.
So Bharti, accuracy level of walls are very high. I think we are at 92% in the point cloud segmentation. In a lot of projects, we see almost all the walls created by machine learning are retained almost 100%. On an average in a month, we see about 80% walls getting retained by the modelers, the walls created by the machine learning system. So especially for walls, we do have very good accuracy.
I think there was this question from Stacy, but Tarika has already answered it from our team. And she has unfortunately left to feed her couple of sons. I think just like you, she has two boys. So any other question, guys? Last call before we wrap this up. Otherwise, you also have the calendar of Varun in the chat box, where you can book one-on-one session with him to discuss further solution. In fact, I think Scott, probably you should go in the calendar and book a session where Varun can probably show you these demonstrations as well about CAD to BIM and PDF to BIM solutions that you were asking about. Any other questions, guys?
I think Mahesh has some question about how much is the energy consumption from the electricity bills. Yes, it is possible, Mahesh. But what it won't tell you is what is the optimization necessary, which walls to insulate first to deliver maximum reduction in your bills. So that's something the BIM model provides. It understands exactly how your house is structured, and when we do all the calculations, we get to know with minimum change, minimum cost, minimum material used, how can you optimize your energy bills most effectively.
So I think, Varun, we have already overshot our time. So thank you so much, Varun, once again. I think the audience will be really happy with the way you have answered their questions. And I'm sure many of you will be reaching out to you and talking to you one-on-one to further discuss how we can further optimize their design workflows and then do it in a better, faster way. So one of the key things that we do in nCircle is do more with less. There is the last question that comes from Vinay Dilip, which is saying, for energy analysis, does scan detect materials?
Currently, no. Right now, we can't detect different materials. We do have, we do need some level of intelligence and other inputs from the surveyors to apply the right set of materials. We built automation to apply materials faster on the different walls and different elements, but automatically not there yet.
All right. So, guys, I think with this, we will bring in a close. Okay, as soon as, all right.
So, I'm not sure if you put in the Calendly link.
We have. Yeah. It's there.
Repeat the link.
Can you? Yeah. So we'll just put the calendar in link once again. Yes. So anyone again, please use this link to connect with Varun directly to further take on these questions and discussions. Thank you, Varun, once again. Thank you to the lovely audience members for making time. And I'm sure you guys had fun. You enjoyed this discussion. This is first of the many episodes that we are going to be come up with in this series of Fireside Chat with Varun Bhartiya, where we'll be unlocking automation 2.0 in AEC. This time around, we spoke about our AI/ML powered scan to BIM and how it can help to reduce the carbon footprint. So stay tuned for many such topics to come in. Thank you once again, everyone. Have a lovely day ahead. Good night, good evening, good afternoon, based on your time zones. Bye-bye.
Thank you. Thank you, everyone.